Number 9. Water flows into a swimming pool at a constant speed as seen in the table. What is the rate of change? Don't forget the units. Rate of change, which if you're looking at it from just a number sense, it's the same as slope, which we know, which is the change in your y's, y minus y over x minus x. You can set them up any way you want to. So in this case, but you have to be careful because usually you're talking about some kind of units. So in this case, these are our x's and these are y's. We're looking at gallons per minute. So if you're going to use 2 points, it doesn't matter which ones you use. And remember, these are just ordered pairs. This is like 4:16, and this one's 8:32. Every 8 minutes, in 8 minutes, there was 32 gallons. So you can use any of the 4. I'm going to use the smaller numbers. I'm going to go on with these 2. And I think I'm going to start with the 32. So I'm going to do 32 minus 16 over my x's, which is 8 minus 4. So I have 16 over 4, which is 4. Now remember where we were going. The y's, which were our gallons. And you can do a slash. You can write per. And then so it's 4 gallons per minute. And this is a continual, got the hose running in it. It's not going any faster. It's not going any slower. Number 10, we're going to solve for x. I'm not sure 28 again goes with these, but it's back when we've done all kinds of equations. We need to distribute this -3, so I think I'm going to do it over here. I've got 8 plus 16x is equal to 12x. I'm just distributing that -3 plus 12. Now, I like to get my x's together first. I'm going to move one of the 12x. So I've got 8 plus 4x equals 12. I like my variable on the left, so I'm trying to get x by itself. And I get 4x is equal to 4. To get x by itself, we'll divide by 4 and get x equals 1. Domain and range. Domain of a set is the x values, the first values. It is a set. And you don't want to repeat these because this means just, like if we say 3, 3, we don't have 2 3's in our number system. So I see a 3, I see a 5, I see a 6, and I see a 9. And it's nice. They came up in order. I don't always ask for them in order. And then the range is your set of y's. Well, in this case, you notice you've got 8, a 2, and a 1, and a 1. So we actually, if you want to put them in order, we'll go ahead and do it since there's only 3 of them. So we've got 1, 2, and 8. And you can put them in any order. Solve this equation for m. Because they're variables, we don't know what y is. And I want to get m by itself. So I'm just going to add y to both sides. Now, our instinct sometimes, y'all's instinct, is to go ahead and say 7 plus y, but you can't add them if you don't know what y is. If y is 3, it'd be 10. But what if y is 5? Then it would be 12. So all we can write is 7 plus y. We can commute that, but we're just going to leave it for now, just like that. So we've got our left side, right side. If I want to get rid of the 2, which is multiplication, we're going to divide both sides. And I get m is equal to exactly what it says. It's just 7 plus y over 2. Number, and I'm so sorry, I just realized you didn't see that. So, added the y, couldn't add them together because I don't know what y is. So I've got 2m equals 7 plus y. Get rid of the 2 because I'm trying to get m by itself. And we get m is 7 plus y over 2. I'll do better on this one. If you're going to simplify, let's put our numbers together. And let's put our exponents together, our base 10s. Well, if you go divide 4 into 4.4, you get 1.1. That's pretty easy, and we like that. It's already between 1 and 10. Now, if you think about, I'll go back to the x like they do in scientific notation. If you think about negative exponents, we never leave them in regular answers. In scientific notation, you can have negative exponents. But if I want to get these together, I can take that 10 to the negative 2 and move it to the top, which would give me 10 to the 16th over 10 to the negative 2. We know that we can move these 2 up, and we'll have 10 to the 16th times 10 to the 2, which gives us 18 10 tens on top. So we've got 1.1, which is between 1 and 10, times 10 to the 18th. Okay. Number 14. We're going to factor completely. Again, let's do it with factor trees. We'd like to be able to do it without, and some of you can. But for those of you that can't, we'll set it up. There you go. The factor tree of 8m squared into the fourth is 2 times 2 times 2 times m times 4n's. And the factor tree of 12m to the fourth n is 2 times 2 times 3 times 4m's times 1n. Well, if you look, you'll see that they each have a 2 times 2, which is a 4. And then in terms of m's, notice this one has 2, this one has 2. And with this one has 4 n's, but this one only has 1, so what they have alike is 1 n. Notice it has a 2 and 3 n's, which we put here, and the second one has a 3 and 2 m's, which we put here. And then you can check it by distributing backwards. Number 15, we're going to distribute, and then we'll do some cleanup if we can. Now let's go ahead and put a 1 under this. We've got x to the fourth times x, so we'd have 5 x's on top. And y to the seventh times y to the fourth is 11 y's on the bottom. And then the second one, we've got a 2 and 1 over here, so I'm just going to go ahead and put a 2. And then 6 x's on top, and 8 y's on top, and then 7 y's on the bottom. 7 y to the 7th over 1 times 1, which is y to the 7th. Now let's see if we can go to reducing. The first fraction is not going to reduce. We have x to the 5th, y to the 11th. And here we can cancel some of our y's because we've got 8 on the top and 7 on the bottom. So I'm going to leave it, and I think I'm just going to section this off, and we'll go right down here. We have x to the 5th over y to the 11th plus, and then we'll have a 2, and then an x to the 6th, nothing cancels with that, and then we'll have 1 y left on top. And you can put the 1 under that if you want to. Number 16, this is called Power of a Power from Lesson 40. We're going to raise everything in here to the third power, so 3 to the third means 3 times 3 times 3, which is 27. And then x to the 5th to the third is x to the 5 times 3, which is 15. Y to the 1 to the third is y to the 1 times 3. And then z to the 2nd to the third is z to the 2 times 3, which is 6. Number 17, find the x and y intercepts of this line. Well, if you want to find and remember we're looking where it crosses the x-axis and the y-axis. And if you're looking for the x-intercept, a number here, then at that point the y would be 0. Everything on the x-axis has a y of 0. So if we put 0 in for y, we'll have negative x plus 3 times 0 equals 9. That's just 0, so we have negative x equals 9. That's negative 1x. So if we divide by negative 1, we'll get x is equal to, and I can barely write it there, negative 9. If we want to know the y-intercept, everything on the y-axis has an x of 0. So let's put 0 in for x. We'll have negative 1 times 0 plus 3y equals 9. This is just 0. You see what I'm writing? I never slide it up enough. So you can come back over here and see what I did. I put 0 in for y and got my x. And then if I put 0 in for x, this becomes 0. So we have 3y equals 9 divided by 3. Y is equal to 3. And I'll put that back up here. This is my x-intercept, and this is my y-intercept. And you could just say x-intercept equals negative 9, y-intercept equals 3, and I even accept x equals negative 9, y equals 3. Now this one says graph a line with an x-intercept of negative 2 and a y-intercept of 4. And I don't think I have any graph paper handy, so I'm just going to slide this up. I'm just going to do a rough sketch of the number line. You will have graph paper for your test, and you can use it for your study guide. You've got your x-axis and your y-axis, and I'm going to put some tick marks on them. I'm going to let them be 1s. Okay, if my line's going to cross the x-axis at negative 2, that means it's going to cross the x-axis right here, And if it's going to cross the y-axis at 4, 1, 2, 3, 4, and I believe I do have a ruler, and I can take my straight edge and connect those, and there's your x-intercept, and there's your y-intercept, which were given to you. Number 19, I think I'm going to keep this piece of paper here. Well, I might have room for it. Stalk of corn cast a shadow of 156 inches. So we've got a taller stalk of corn, and it's shadowed down here on the ground, and I'm not going to put units just for the sake of the not having a lot of room. And a little 6-inch ear of corn has a shadow of 13 inches. And this has to be at the same time of day. And it says, what's the height of the corn? Well, as long as you go the same direction, you can set these up as a proportion. So I'm going to say x is to 6 as 156 is to 13. You can go x is to 156 as 6 is 13. You can set them up as long as you match them up correctly. Now let me add a piece of paper under here and get the rest of the work for you. Let's do it as a proportion. Actually, 13 will go into 156 evenly, and you can work it that way, but it doesn't always set up like that, so I'm going to cross multiply and get 13 times x equals 6 times 156. And I'll come over here and multiply that. 33. So I've got 13x equals 936 divided by 13. We'll do that work down here. Let me slide it up just a little bit. Okay, 13 goes into 93, goes about 5, 6, 7 times. 7 times 13 is 91. You have 26, and 13 goes into 26 2 times. So you have x is equal to, and remember we were in inches, so it's 72 inches. And you could convert that back to 6 feet if you wanted to, but we were given it in inches, so we'll just leave it as that. We're looking for the 8th term of this sequence, so you want to see what your pattern is. You're subtracting 2. And I'm going to go 1, 2. This is my a sub 1, 2, 3, 4, 5, 6, 7, 8. So 2 minus 2, minus 2, minus 2, minus 2. So my 8th term should be -6.